Hello everyone, welcome to my new Data Structures and Algorithms in Java tutorial series video. In this tutorial we will discuss how to insert a node at the end of a singly linked list in Java. So friends, below you can see the algorithm to insert a node at the end of a singly linked list in Java. So here in this tutorial we will see the demonstration of this algorithm step by step. Here the algorithm basically insert the node to the end of the singly linked list. So let's suppose at the start the singly linked list is empty. So if the singly linked list is empty, we know that head will point to null because there are no nodes into the singly linked list. So now let's suppose we want to insert a node having data as 11. So to the method we'll pass the value as 11 and this code will be executed. So in the first step what we do is, in order to insert this value into the singly linked list, we first actually create a list node by passing in the value to its constructor. So it would look something like this, that a new list node is created whose data is 11 and whose next is pointing to null. So now we will insert this new node into the singly linked list at the end. So first here in the algorithm we check that whether head is equal to null or not, because if head is equal to null then we know that singly linked list is empty and there are no nodes. So therefore currently singly linked list is empty because head is pointing to null. So the condition in if block comes out to be true. And in the if block we simply assign the value of new node to head. So new node is pointing to a node having data as 11 and we want to insert this new node into the singly linked list at the end. But here as the singly linked list is empty, therefore in the first step what we do is we simply assign the value of new node to head. So here as head is pointing to null, after this assignment head will point to this node having data as 11. So it would look something like this. And we'll simply return from this method. So friends, here we inserted one node into the singly linked list at the end. So initially the singly linked list was empty, but now it has one node where head is pointing to this node. Moving ahead, let's say we want to insert one more node having value as 8. So we will pass this value into this method. And the first step will simply create a new list node by passing in the value to its constructor. So it would look something like this, that new node is pointing to the node having data as 8 and whose next is pointing to null. Now we want to insert this new node to the end of the singly linked list. It's nothing but just after the node having data as 11. So friends, now we want to insert this new node to the end of the singly linked list, and here you can see that singly linked list has only one node. Therefore this node having the data as 11 is the last node of the singly linked list. So now after this node we have to insert this new node. So we again check whether head is equal to null or not. So currently you can see the head is pointing to the node having data as 11. Therefore the condition in if block comes out to be false. So here we simply create a temporary node by name current and we'll assign the value of head to it. So it would look something like this, that current is now pointing to the node having data as 11 and head is also pointing to this node. Moving ahead. So friends, now we actually provide a while loop. So why we are providing this while loop is because in order to insert a new node to the end of the singly linked list, we need to traverse from head to the end node. So once we reach the end node, we can simply assign the value of the last node next to point to this new node. Therefore we start from the head node as current is pointing to head and we'll iterate in the while loop till current.next is null. So friends, when current.next will be equal to null, therefore we can come to know that that is the last node of the singly linked list. So friends, in the while loop we provide a condition that current dot next is not equal to null. So here if you see, current is pointing to the node having data as 11 and its next is pointing to null. And we also know that currently in the singly linked list there is only one node having data as 11 and its next is pointing to null. So therefore the current is pointing to this last node. So therefore the condition in while loop comes out to be false because current dot next is equal to null. So as the singly linked list has only one node, therefore this node is the first and also the last node of the singly linked list. So as we are on the last node of the singly linked list, in order to insert this new node to the end of the singly linked list, what we do, we simply assign the value of new node to current's next. So here you can see new node is pointing to the node which we want to insert and current's next is pointing to null. So if we assign the value of new node to current's next, it would look something like this. That current's next is now pointing to a node which we want to insert into a singly linked list at the end. So friends, when this method gets executed, we know that we have inserted this new node to the end of the singly linked list. Now let's suppose we want to insert one more node having value as 1. So this code will be executed again. In the first step, we'll simply create a new list node by providing in the value as 1. So it would look something like this. That new node is pointing to a list node having data as 1 and whose next is pointing to null. We check whether head is equal to null or not. So here you can see head is pointing to a node having data as 11, therefore it's not equal to null. So friends, in order to insert this new node to the end of the singly linked list, we have to start from the head and we have to reach till the last node of the singly linked list. So in order to perform this step, we simply create a temporary node by name current and we start it from the head by assigning the value of head to current. So it would look something like this. That current is pointing to this first node having data as 11. Now we will simply provide a while loop and traverse this current to the last node of the singly linked list by providing a condition that current.next is not equal to null. So in the first step we see current is pointing to a node having data as 11 and its next is pointing to a node having data as 8. Therefore current.next is not equal to null. So the condition in while block comes out to be true. So in the while block we simply traverse current to its next position by assigning current.next value to current. So here you can see current is pointing to this node having data as 11 and its next is pointing to a node having data as 8. So we'll assign the value of current.next to current. So it would look something like this. That current has simply traversed to its next node because we have assigned the value of current.next to current. Moving ahead, we will again check whether current.next is equal to null or not. So here you can see current.next is equal to null, and here we also know that singly linked list has two nodes. So the node having data as 8 is the last node of the singly linked list. So we have traversed the current to the last node, and now we can simply insert this new node to the end of the singly linked list. So here the condition in while block comes out to be false because current.next is now pointing to null. And in the last step we simply assign the value of new node to current's next. So new node is pointing to the node which we want to insert and current next is pointing to null. So if we assign this value to current next, it would look something like this. That current next is now pointing to the node having data as 1. So friends, once this method gets executed, we know that our singly linked list has now 3 nodes. So here we started by inserting a node having data as 11, then we inserted a node having data as 8, and then we inserted a node having data as 1. So you also saw that we are actually inserting this node to the end of the singly linked list. So friends, this was a demonstration of the algorithm. Now let's go to Eclipse and see the working of this algorithm.